Okay, so in this video, we'll be discussing the questions from paper 6, the probability and statistics 2, which is from the February-March 2021 paper 6-2. Okay, alright, so we'll start with question number 1. Alright, so there's a construction company notes the time about in T lah, okay, so we are calling it as T days. We are measuring in days that is take to build each house of a certain design. So the result for a random sample of 60 such houses are summarized as follows. So we are having some details about the houses. Summation of T is 4820. Summation of T squared is this value. So first of all, they want us to calculate the 98% confidence interval for the population mean time. Okay, so for your information, to get a confidence interval formula, the general formula for confidence interval, it will be actually, this is for mean, right? So I will need the sample mean minus the z, then sigma over square root n. Then the upper limit will be sample mean plus z, then multiply with sigma over square root n. Okay, so there's no problem for us to find out the sample mean, I believe. Okay, and then what is the sigma here? So this particular sigma here, basically we are talking about the population standard deviation. Alright, so if you have a look for our information here, right, given in the question, we basically don't have population standard deviation. And we need to actually estimate this population standard deviation from the value, okay, from the sample given. Okay, so you need to actually estimate the population variance or population standard deviation. Then only you can continue to get the answer for confidence interval. Alright, so let's start our calculation here. First of all, I will want to calculate the estimated mean from the value of sample. So estimated mean, right, basically the value is the same as the sample mean also lah. So I'm having summation of T divided by N. And the answer is 4820 divided by 60. So if I simplify it, I will have 241 over 3. I will keep it in the fraction form because later I want to substitute this whole equation, this whole value inside my confidence interval formula. Right. Okay. And then I need to estimate also the population standard deviation. So for the estimation of population standard deviation, we'll call it as unbiased estimated variance. Alright, so it's an unbiased estimated variance. If you can't remember the formula, basically the formula is provided in the formula booklet lah. So you can have a look for MF 19. And then I think at page number 8, then you scroll down for this part, you can see that unbiased estimator. So the unbiased estimator variance, there are two. This is the first one. This is the second formula. According to the formula given, right, according to the information given in our question, we are having summation T square and also summation T. So this is more suitable, right? So we'll use this formula to calculate the unbiased estimated variance. Right, so let's come back to this question. The formula for unbiased estimated variance is 1 over n minus 1. Then I'm having summation x squared minus the summation x squared over n. So if I substitute in all the value, I will have 1 over 59, then 392050 minus 4820 square divided by n. So my n is 60 here. Then if you try to press the calculator, right, you'll get a long value. I'll keep the long value originally, because I want to make sure that my final answer later is as accurate as possible. Alright, so this is my unbiased estimated variance. Okay, so we have the sample mean, which is the same value as the estimated mean. We have the unbiased estimated variance. So now, to get the confidence interval, we need to find out the value of Z. So this value of Z basically depends on the percentage, the confidence level of the confidence interval. So we are having 98% confidence level. 98% means that to find out the value of Z, it actually covers like this. Okay, so it is actually 98% in the center. Okay, so this is the value of Z. Since they are symmetrical to each other for both sides, so I'm having negative Z and Z. So if this is center part where I'm having 0.98, right, which means that the small area here will be equals to 0.01, and this small area here will be also equals to 0.01. To find out the value of Z, I need to consider the area below or maybe on the left hand side of the Z. So I need to consider this whole area here. So you have to take 0.98 plus 0.01. So you're having 0.09 if you add these two together. Oh, sorry, 0.99. Okay, so that means to find the value of Z, when you refer to the table, go to the normal table here, maybe you can try to refer to the shortcut table. Okay, the critical value. We are looking for the area 0.99. So this is the area for 0.99 and the value of Z is actually 2.326. So for this particular equation here, for this particular question, my Z is 2.326. Right, so we come back here. Okay, so we already have all the value, right? So Z is 2.326. I just put it down here first. Okay, so we'll apply this formula, yeah. 98% confidence interval equals to, okay, so if I write out the original formula, is something like this. Okay, so to get the most accurate answer, I will always substitute the original value. So for this one, it's a fraction 241/3. Then minus the Z, which is 2.326. Sigma is square root of this value, right? So I will take square root for the variance. And when I substitute, I'll substitute the whole value here. Divided by n. N is 60. Then same thing happen for the upper limit, 241/3 plus 2.326, and then square root of the variance, 82.09039,548, then divided by 60. Okay, alright. So you just substitute all the value inside the equation into the formula, and after that you'll get your final answer for confidence interval. And of course, our final answer, I will want to correct it to 3 significant figure, and it will look something like this, which is 77.6 for the lower limit, then 83.1 for the upper limit. Okay, so this is how we actually get the answer for the 98% confidence interval. Alright, then let's continue to part number 2. Part B, they want us to explain why it is necessary to use the central limit theorem in part A. So if you have a look for this question, right, in this particular question here, basically they didn't mention what is the distribution of the population. They didn't tell us that the population is normally distributed. Alright, so you won't see any keyword about normal distribution. Therefore, since the population distribution is unknown, therefore we have to apply the central limit theorem. Okay, so they're asking us why. So basically the reason is the population distribution is unknown. Population distribution is unknown. And that's why we have to use the central limit theorem. Okay, that implies that when our sample size are large, then our sampling distribution is approximately normal. Okay. Alright, so this is how we answer question. Okay, so we come to question number 2. We are given a diagram and it shows the probability density function of a random variable x. Okay, so for any probability density function, we need to know that the area under the graph is always equals to 1. Okay, alright, so they want us to find the value of the constant k. Okay, so to find the k, first of all, we want to use the idea like where I mentioned just now. When you are having a probability density function, right, the area under the graph must be always equals to 1. So you can see that we are having the area under the graph, it belongs to the area of a triangle, right? Okay, it is the area of a triangle. Therefore, I will use the idea area of the triangle should be equals to 1. Okay, how can I find the area of the triangle here? So I'm taking half times base. What is the base? So the base here is k. And then what is the height of the triangle? So the height of the triangle is half k. And that equals to 1. Okay, Alright, then when you're having half times k times half k, you're having 1 over 4k squared equals to 1. Therefore, your k squared equals to 4 and your k equals to plus minus 2. Okay, should I accept both answers of k or should I accept only one of them? So if you have a look for the diagram, right, you can see that k, this particular value of k should be a positive value right, from the graph. Therefore, to make sure that it is a positive value, we only accept the k equals to 2 and we ignore the value k equals to negative 2. Okay, so this is how we found the value of k here. Alright, then let's continue to part number B. For part number B, by using this value of k, find function fx for 0 until k, and after that, find the ex. So first of all, we need to find the function first for this particular graph, and after that, we need to find out the ex. Alright, so if I have a look for the function here, this is a linear line, right? Linear equation. So this particular red color line here is a linear equation. So for this linear equation, the general formula will be y equals to mx plus c, right? Okay, so y equals to mx plus c. And then from this question, I actually know that I'm having two useful points here. One point is this one. This one is when your x equals to 0, then your y is equals to half k. Okay? Then another one. What is the other value? So the other value is this one. Okay? Then when x equals to k, y equals to 0. Okay? So now, I will want to substitute the value here by using either point. Okay? So the k0 here basically means 2, 0. Okay, so maybe I want to substitute this particular point into the linear equation. Okay, so I want to substitute the point 2, 0 into my equation here so that I can get the value of m. But at the same time, I also need to know what is the c. C is actually y-intercept, right? If you have a look of the diagram again, this particular value is y-intercept. So what's the value of y-intercept here? It is actually a 1. So this one is a c, this one is my x, this one is my y. So substitute c, x, and y into the linear equation, then you can get the gradient. Alright, okay, so again, my y equals to 0, x is 2, right? So I'm having 2m, then plus c, c is equals to 1. Therefore, I can get the gradient of this equation, which is negative half. Alright, so again, to write out the function, the line in the function form, it will be fx, which is the y, equals to mx plus c. So I'm having negative half x, then plus 1. Okay, so this is my function of the particular line shown in the diagram above. Okay, so after I found the fx already, they want us to find out the expected value of x. So how can I find out the expected value of x? Okay, so to find out expected value of x, the general formula is you need to multiply the x together with your function fx, okay, by using the limit for the whole domain given. Okay, so I will start the integration now. Alright, so the whole domain given is from 0 until 2, because you can see that your graph is defined from 0, from here until here, which is from 0 until 2. Okay, so the limit will be 0 until 2. X, I just copy it with the x, and I want to multiply with my function fx, which is negative half x plus 1. Okay, so before integration, I need to multiply the x inside. Then only I start my integration here. I will have negative x power 3 divided by 6, then x squared divided by 2. Then putting 2 and 0. Okay, substitute 2 into the x here. You'll get negative 8 over 6 plus 4 over 2. Then substitute 0 here. Generally, you're having everything with 0. Okay, so simplify this particular expression here. You'll get the final answer for the mean or expected value of x, which is 2 over 3. So let's continue with the part C. Alright, so for part C, they want us to find the value of P so that the probability of X between P until 1 is equals to 0.25. Okay, so this is the information given. Okay, so for any continuous random variable, right, to find out the probability, again, you need integration. So since they mentioned that the X value is from P until 1, right, therefore the integration limit will be from P until 1. And then what's the function that we have just now? We are putting in the function fx, which is negative half x plus 1. And I let it equals to 0.25. Okay, so we'll start the integration now. I'm having negative x squared over 4 plus x. Put in the value 1 and p, and it is equals to 0.25. Okay, substitute 1 first. I'm having negative 1 over 4 plus 1. Substitute the p, I'm having negative p squared over 4 plus p. It is equals to 0.25. 0.25 is 1 over 4, as actually. Okay? Alright, then if you try to simplify slowly, simplify all the number together. Okay, then maybe I want to make the 4 disappear. Therefore, I multiply the whole equation with the 4, right? So I will have something like this. Okay, so if I continue to simplify it, I will have p squared minus 4p plus 2 equals to 0. So you can see that I get the quadratic equation actually. And now I want to find the value for p. So to find the value of p, what you can do is you can use the quadratic formula. If you want to try to factorize, you can, but very obviously this one cannot be factorized nicely, right? So I will use the quadratic formula, negative b plus minus square root b squared minus 4ac, then divided by 2a. Okay, so if I further simplify everything slowly, I will have 4 plus minus square root 8 divided by 2. And then if I continue further, then I will have 2 plus minus square root 2 if I simplify further. Okay, alright, so from here, you are having two values of p. P equals to 2 plus square root 2, and also p equals to 2 minus square root 2. Okay, so for these two values of p, right, which one should I accept? Alright, so if you have a look for the question, you can see that the p value basically should be smaller than 1. Because the limit they start from the p, right? So p should be a smaller value and it shouldn't be more than 1. So if you try to observe, 2 plus square root 2 will give you a value which is more than 1. So I have to ignore this particular value for the p, and I accept only this one where p equals to 2 minus square root 2. Or if you change it become 3 significant figure, it should be 0.586. Alright, so this is how we solve question number 2. Okay, so we are at question number 3 now. There's an architect wish to investigate whether the building in a certain city are higher. Maybe you can highlight the keyword higher. This is actually the keyword to help us to form the alternative hypothesis. Okay, right, so to investigate whether the building in a certain city are higher on average than buildings in other city. Okay, so he take a large random sample of building from the city and find the mean height of the building in the sample. And he calculate the values of the test statistic. He finds that the test statistic equals to Z equals to 2.41. Right. Okay, so first question, they want us to explain briefly whether he should use a 1-tier test or 2-tier test. So I think it is quite obvious because when you see the keyword higher, right, that means basically they want to test whether the population mean for that particular city, okay, is more than something or not. Alright, so higher means greater than. So for the sign greater than, right, you can see that we are going to run the test for right hand side only, which is a 1-tier test. Alright. So you can write it like this. So it is a 1-tier test. So you need to explain briefly why is it a 1-tier test, because we want to investigate whether the buildings are higher. So the higher is actually one of the keyword tell us about the one-tail test, right? Okay, so for part number B, they want us to carry out the test at the 1% significance level. Alright, so again, for this particular test, right, we are going to run the test on the population mean, okay, for the buildings in a certain city. Okay, if you try to read the question here, right, you will realize that there's no population mean given. Okay, there's no particular value of the population mean is given in this question. Therefore, how am I going to set up the null and also alternative hypothesis? Okay, so for most of the question that we try to solve before, right, when you want to set up the null and alternative hypothesis, usually we use a number. As an example, like, oh, the population mean is equals to a value, and then we want to test whether is it higher or not, so population mean is greater than a certain value or not. Right? But for this question, they totally didn't give us anything about the value of the population mean. Therefore, when you want to set up the null and alternative hypothesis, right, you have to write out the statement by yourself without the value. So that means if let's say for the alternative hypothesis, right, we want to test the building are higher. So we will set alternative hypothesis as the buildings in a certain city is higher than the other city. Okay, then how about the null hypothesis? So the null hypothesis is the building in a certain city is the same with the other city. Alright, okay. So the keyword that must be shown here is you need to write a sentence roughly with the meaning of this, and then maybe the keyword here will be is the same, and then the alternative hypothesis should be higher, right? Because when we usually set up the null hypothesis, it should be mu equals to something. Equals to means should be the same, right? So same. And then when you set up the alternative hypothesis, we are talking about mu greater than something. So greater than in this statement, it should be the word higher. Okay, so this is the first step where we already set up the null and alternative hypothesis. Okay, so after that, we need to know where is my rejection region. If you have a look for this question, right, they already tells you that we are having a large sample, large random sample. So by using central limit theorem, we can assume that the sampling distribution here is normally distributed, is approximately normal. Therefore, when you want to carry out the test, right, we will have I want to know where's my rejection region first. So this is a one-tail test on the right hand side. Therefore, my rejection region will be on the right hand side as well. So I shaded this rejection region here. How large is this rejection region? So it is our significance level, which is 0.01. So this particular area is 0.01. And now I want to know what is my critical value. Okay, I want to know what's the limit of the critical value that separate the rejection region and also the acceptance region. So to calculate the critical value, you need to find out from the table. Okay, so to find out the value from the table, right, you need to know what is the area below or on the left hand side of this value. So the area on this left hand side here is 0.99. So again, you need to scroll down to the shortcut table, the critical value for the normal distribution. Then look for the area 0.99 and the Z is 2.326. So which means that if you come back to this question here, our critical value, it will be equals to 2.326. Okay, so once you figure out the critical value already, and now you want to check your test statistic and see whether it is located under the rejection region or under the acceptance region. Okay, so what is my test statistic here from the sample? So from that particular sample, right, when you try to do any calculation or whatsoever, the test statistic that you get is 2.41. So I want to place the 2.41 in my graph here. So where is 2.41? your critical value is 2.326, so 2.41 should be after the 2.326, right? Is it 2.41? 2.41. Okay. So you can see that my test statistics falls under the shaded area, which is the rejection region. Okay. So before we can make any decision here, you can write the reason. Because the test statistics is equals to 0.24, it is more than the critical value, which is equals to 2.326. And if you want to see clearly, you can imagine this diagram in your mind, and you can see that the 2.41, okay, so you can try to sketch this diagram, and then you will see that the 2.41 basically falls under the rejection region. The shaded region means rejection region. Okay, so since the test statistics fall under the rejection region, therefore our conclusion will be reject the null hypothesis. And then what is the conclusion in the question context? So you can say that there's sufficient evidence to show that the buildings in a certain city is higher. In a certain city is higher than other city. Okay, so this is basically how we carry out the test. Even though we don't have the value for the population mean, but you can just write out the null and alternative hypothesis in the statement form. Alright, okay, so this is how we solve question number. Okay, so question number 4. On average, 1 in 400 microchips made at a certain factory are faulty. So the 1 in 400 are faulty. Basically, this one, it has a meaning of proportion or percentage. Okay, that means 1 out of 400 are faulty. So basically it's about the probability. Okay, so this is a probability of 40 chips. And then the number of 40 microchips in a random sample of 1000 is denoted by X. So we're having a large value, okay, of a random sample which is 1000. So state the distribution of X given the value of any parameter. So for this question, right, the first part here we are given the something about proportion. Then this one is a large sample value, which is maybe a total number, okay, of the sample, the total number of the microchips. Therefore, it actually belongs to a binomial distribution because you're having a fixed number here, which is 1000, and we are given the probability, which is 1 over 400. Okay, so it is binomial distributed with the n is 1000, the p is 1 over 400. Okay, then after that, they want you to state an approximating distribution for the X given the value in any parameter. So for A2 syllabus, right, our binomial distribution originally, okay, can be approximate to horizon only. Binomial to normal is in AS statistic 1. Okay, so for A2 syllabus, stats 2, the approximating distribution is from binomial become Poisson. So how can I get the lambda in Poisson? So the lambda, the parameter in Poisson, right, basically is mean. So how can I get the mean from binomial? So to get the mean from binomial, it will be n times p. So I will take 1000 multiply with 1 over 400 and I get the mean, which is 2.5. Okay, alright, so from here you should know that binomial can be changed into Poisson distribution. To get the lambda or the mean, you can just take n times p, because from the formula of binomial, to get the mean it is n times p, right? Okay, and then for some of you, if you want to know under what condition you can change binomial become Poisson, generally there are a few conditions that you need to know. The n must be large enough, which is greater than 50. And also the value of n times p must be small enough, and it should be better greater than 5. So it's smaller than 5. Alright, so this is the condition basically, if you want to know when can you change binomial become Poisson. Right? Okay, so this is what you have for part B. Then let's have a look for part C. For For part C, they want us to use the approximating distribution to find each of the following. So using approximating distribution, okay, so just to recall back, just now we already changed binomial become Poisson distribution and the lambda is 2.5. How to calculate the probability for x equals to 4? Okay, so the general formula is E negative lambda, then lambda power r divided by r factorial. Okay, so for our equation here, it will be E negative lambda, lambda is 2.5, then lambda power r, r is the value of x that we want to find, so it's power of 4 divided by 4 factorial. So try to simplify this particular answer, correct it to 3 significant figure, it should be 0.134. So this is a straightforward question. Okay, then how about for part number 2? They want you to find the probability for x from 2 until 4 under a Poisson distribution. So the value, the probability for x between 2 until 4 basically is, you need to include the probability for x equals to 2, the probability of x equals to 3, and also the probability of x equals to 4. Okay, so if I want to factorize out the formula here, right, for these 2, 3, and 4, I can factorize out the E negative lambda. If I factorize out E negative lambda, I'm having E negative 2.5. When x equals to 2, this part, lambda power r divided by r factorial will become 2.5 power 2 divided by 2 factorial. Same thing happens for the 3, x equals to 3, I'm having 2.5 power 3 divided by 3 factorial, and also 2.5 power 4 divided by 4 factorial. Okay, and then again, press the calculator and get the value correct to 3 significant figure. You should get 0.604. Alright, so this is how we answer part C. Continue further to part number D. Okay, then now again, use a suitable approximating distribution. So you see the keyword approximating distribution again. Now my random sample is not 1000 anymore, it becomes 700. There will be at least 141. Okay, so again, we need to start from the beginning. Right, so instead of 1000 just now we are having a random sample of 700. So it is still the same rate, where 1 out of the 400 microchip is a 41. Okay, so change it become Poisson still, because if you double check the condition, right, n is still greater than 50, n times p basically still less than 5, right? Okay, so you want to change it become Poisson distribution. So you take 700 multiply with 1 over 400, so you have 7 over 4 as your lambda. And now they want us to calculate the probability that x greater equals to 1, at least 140. So x greater equals to 1, you have to take x equals to greater equals to 1 means that you have to take x equals to 1, x equals to 2 plus x equals to 3 and then x equals to infinity, which is impossible for us to complete it, right? So I have to take 1 minus x equals to 0 to get the probability of x greater equals to 1. So x equals to 0 probability is E negative lambda. Then I'm having lambda is 7 over 4 power 0 divided by 0 factorial. Okay, so if you try to simplify the answer, you should get 0.826. So this is how we answer question number. Okay, so question number 5 now. We are having the volume in liter of juice in large and small bottle. So we are having 2 types of bottle, large and also small. Maybe for the large one, I will label it as L. Then the small, I will label it as S. Okay, so both L and S, right, has the distribution N. Okay, so highlight the N here. So these two types of bottle basically are both normally distributed. Okay, so you can see very clearly the N here, which is the normally distributed question. Okay, so they want us to find the probability that the total volume of juice for 3 large bottles and 4 small bottles less than 25.5. Highlight the keyword total. So total means that you need to add the volume for 3 large and also 4 small bottles, okay, before you can calculate the probability. for 3 large bottle, right? By right, you should write L1 plus L2 plus L3 lah. Because I'm lazy, so I just straight away write as 3L. Okay, but I know that it is actually a summation of 3 different bottles. Okay, then plus 4 small chosen bottles. So by right, you should write S1 plus S2 plus S3 plus S4. But again, because I'm lazy, I will write it as 4S. But from here, I know that the 4S basically means that it is the total of 4 different bottles. S1 plus S2 plus S3 plus S4. Okay, so before you can calculate the probability for 3L and also the 4S, right, the total for 3 large and 4 small bottles, I need to know the mean first. Okay, so to calculate the mean for 3 large and also 4 small bottles, basically you have to take 5.10. 5.10 here is the mean for the large bottle, plus 5.10 plus 5.10 3 times. Okay, so basically I write as times 3. Then plus 4S. So what's the mean for 1S? So the mean for 1S is 2.51. So I have to take 4 times 2.51. But the original meaning is you have to take 2.51 plus 2.51 plus 2.51 plus 2.51. Okay? Then when you simplify the answer, you will get 25.34 here. Okay, then we also need to calculate the variance. Again, when I write 3L and 4S here, but basically I know that it is L plus L plus L plus L plus L plus L and also S plus S plus S plus S, 4S, okay? Okay, so when we are having the variance, right, to calculate the variance, it should be 3 multiplied with the variance of L. So what's the variance of L here? 0.0102. Okay, then plus 4 times, okay, the variance for 4 small bottle. So I will take 4 multiplied with the variance for the small bottle, which is 0.0036. And if you apply the calculation like this, then you will get 0.045. Okay, huh? Alright, so maybe for the common confusion that students have is, they are not so sure when do I need to square the 3 and also the 4 under the variance part. Okay, so for this question, there's no square for the 3 and also no square for the 4. It is because of, in this question, we are talking about the total volume. Total, that means plus. So when you have all the variance, so we have variance L plus variance L1 plus variance L2 plus variance L3. So if you simplify, it should be 3 times of the variance L. So there's no 3 square. Okay, but we are talking about times. Like if let's say I'm having, find the probability that I have the 3 times, the total of 3 times of 1 large bottle. They are talking about 3 times of 1 large bottle. 1 large bottle times 3. So in that case, you need to square, okay, your 3 under the variance part. You understand or not? So for this question, we didn't square the 3, we didn't square the 4 because of we are having the total for 3 large bottle and also 4 small bottle. So for the 4 small bottle, basically is variance S1 plus variance S2 plus variance S3 plus variance S4. So when you simplify, it should be 4 times of variance S. Okay? Alright. So once you get the mean and also the variance, then you should actually know if your original distribution are both normally distributed. When you have the linear combination 3L plus 4S, they will be also normally distributed. Mean is 25.34 and the variance is 0.045. Sorry. Okay, and then for this question, they want us to calculate the probability that the 3L plus 4S, right, the total volume less than 25.5. So less than 25.5. Since we know that this is normally distributed, right? So to calculate the probability, you need to change it become Z. Standardize it become Z. How you standardize it? You have to minus the mean. Okay, so you minus the mean that you calculated just now, then divided by standard deviation. So the 0.045 is variance. So if you want to divide it by standard deviation, it will be square root 0.045. Alright, then again, simplify the value of z, correct to 3 decimal places, 0.754. Then you can try to get the probability from the normal distribution table. My value of z is 0.75. So by right, this is the value that you have. And then for the 4 here, you need to add 12 at the last 2 digits. So 7734 plus 12. You are having 7746, right? Okay. Then, so you can find out the value here. For the area, it will be 0.7746. Correct it to 3 significant figure. Your answer should be 0.775. Alright, so this is how we answer part A. And let's continue to part number B. Okay, so for part B, now they also want us to find out the probability of the volume of juice, where a large bottle means L, okay, is at least, highlight this one at least, so greater equals to twice. So twice has a meaning of 2 times, right? So this one is multiply one, okay, 2 times. So twice the volume of juice in a randomly chosen small bottle. So L greater equals to 2S. When you want to calculate the probability like this, you're not able to calculate it. You have to move all the variable to one side so that it becomes L minus 2S greater equals to 0. Okay, so before I can calculate the probability, I need to find the mean for L minus 2S. Okay, so L, the mean for L, okay, you can try to have a look from the question. So the mean for L is this one, 5.10 minus 2 times of the mean of S. So 2 times the mean of S is 2.51 and you get 0.08. If I want to find out the variance for L minus 2S, variance of L is 0.0102. Okay, so for variance, there's no negative sign. It will be always positive. So we are having a plus here. Then for the 2, I need to square it. Then the variance of S. The variance of S will be 0.0036. Okay, so again, why do I need to square the 2 for the calculation of variance in this part? It is because of the keyword here. They are talking about we have one small bottle, but it is 2 times of the small bottle. Therefore, when you're having the meaning of times 2, right? When you want to calculate the variance, basically you need to square the constant term, the constant, so which is 2 squared. Then you try to simplify your variance value. This is the variance value that you have. Okay, so I can write out the distribution. So L minus 2S is also normally distributed. Mean 0.08. Variance is 0.0246. Okay. Then for this question, originally they want to find out the probability where L is greater equals to 2S, right? So I did mention just now, you cannot find out the probability if both sides got variable. You have to move it to one side. Then make it greater equals to 0. Okay, then since I know that L minus 2S is normally distributed, therefore to find out the probability, I have to standardize it become Z. So again, how to standardize it? You have to minus the mean that you calculate just now, divided by standard deviation. Okay, then get the value of Z by using calculator. Okay, so we want to find out the value, okay, the probability that Z is greater than negative 0.510. So if let's say this is negative 0.510, we want to find out this area. So it is actually the same. If I want to reflect it to the right side to have the positive value of Z. So that means if I'm having 0.51, right, the area is equals to this one. Right, so to find out the area, basically I can get the value directly from the table. So looking for Z is equals to 0.51. 0.5 1. So by right, this is my answer, right? 0.695. Okay, so I'm right as 0.695. This answer is already correct to 3 significant figure. Alright, so this is how we answer question number 5. Okay, so we are now at the last question, question number 6. It is known that 8% of the adults in the town own a Chantal car. Okay, I don't know what is it. Maybe it's a brand. So after an advertising campaign, the car dealer wished to investigate whether this proportion has increased. So highlight the keyword increase. This is the keyword to help us to set up the alternative hypothesis later. Okay, so he chose a random sample of 25 adults from the town and notes how many of them owns a car. So he finds that 4 of the 25 adults own a car. So the 4 here will be the observed value, where we'll use it to calculate our p-value later. So this is the observed value. Okay, so they want us to carry out a hypothesis test at a 5% significance level. Alright, so for this question, right, basically they are talking about the proportion and we are testing about proportion. Okay, so first step, we need to set out the null and also the alternative hypothesis. What is the value for the population proportion? Originally, they are giving us as 8%, so which is equals to 0.08. And now, they want us to test whether the proportion has increased. So the keyword increase tells us that it's greater. So I'm having P greater than 0.08. So this is the first step where we set up the null and also the alternative hypothesis. Okay, so we go to the second step. We need to calculate the p-value. Okay, basically for this test, right, to test about the proportion, okay, we are using binomial distribution, where you can see that the total number of adults that you have is 25, and then those who own a car, one adult who own a car, probability is 0.08. So we'll carry out the test by using binomial distribution if you want to test about the population proportion. Okay, and then now we need to find out the p-value, right? So the p-value, it depends on the observed value given in the question. So for the observed value given is 4 for our example here, for our question here. So I want to calculate the probability for x and then 4. Okay, so what is the sign here? Should it be greater sign, greater equals to 4 or smaller equals to 4? So one way to decide is you can always observe the alternative hypothesis. So you know that this is greater than, right? Therefore, our alternative, our calculation for p-value, it will be x greater equals to 4. Okay, so please take note that the sign here follow the alternative hypothesis, but it always include that particular value. That means it always has the equal sign here. Because in the question, they already tell you 4 is included, 4 adults, the 4 is included. Therefore, when you want to calculate the p-value, you should include the 4. The equal sign should be included here, right? Okay, so now, we want to calculate the probability for x greater equals to 4 by using a binomial distribution. The easier way will be you have to take 1 minus x equals to 0, x equals to 1, x equals to 2, and x equals to 3. Okay, so you need to take 1 minus x equals to 0. So x equals to 0 will be 25, C0, 0.92 power 25. Then minus x equals to 1, so 25C1. Then minus x equals to 2. And then minus x equals to 3. Okay, alright, so when you try to find the probability for x greater equals to 4 by using the observed value given in the question, the answer that you get is a probability, right? Just press the calculator very carefully, you should have 0.135. And this particular value for 0.135, we actually call it as p-value. Okay, so what are we using? How are you going to use this p-value? We will use it to determine our decision, whether we want to reject or accept the null hypothesis. Okay, we have to compare the p-value with the significance level. Alright, so again, sometimes it's very hard for me to memorize the result. So usually what I do is I will try to use a simple diagram. Okay, to let myself understand what happened here. Okay, so you actually should know that this diagram, the diagram that I draw here is not the correct diagram, but it just helped me to visualize the whole cases here, the whole case here, the whole question here. Right. So if I'm having my binomial distribution, so I will have x equals to 0 and then x equals to 25 for this particular question. Okay, then where is my rejection region? So P is greater than, therefore my rejection region will be on the right hand side. So for the rejection region on the right hand side, right, so maybe I will just again shade it. Okay, I will shade the region to denote that this whole answer here, this whole area here is the rejection region, which is 0.05, this whole area. Okay, right, so this is a rejection region. And now I already have the p-value, so p-value is 0.135, right? So if you observe from here, 0.135 is the area larger than 0.05. That means the area should be this purple color part, larger than 0.05. So this purple color part is actually 0.135. Okay, it's actually 0.135, the purple color here. And what you can do now is, actually it tells you that when x equals to 4, right, this particular line, x equals to 4, because area more than 4 is 0.135. So this particular x equals to 4, the line falls under the acceptance region. You can see that the no shaded one is the acceptance region. So you can see that the 4 falls under the acceptance region. Therefore, you should accept the null hypothesis. Okay, so this is how I decide usually. But again, this diagram basically is not the correct diagram. Okay, but it is just help me to visualize it only. Alright, so this is not the correct one, so please don't draw this in exam. Okay, alright, but from here I know that the number 4 falls under the acceptance region, so this help me to do a conclusion here. Okay, so before I can make a conclusion, right, you still need to write out the reason. So your p-value is equals to 0.135 and it is greater than the alpha significance level, which is equals to 0.05. Therefore, you can see that the 4 falls under the acceptance region, and our conclusion will be do not reject the null hypothesis. Okay, so if I do not reject the null hypothesis, right, you should make a sentence that concludes in the context of the question. So I can say like this. So since we do not reject the null hypothesis, right, that means there's insufficient evidence to show that the proportion of owning a car has increased. There's no evidence to show that it has increased. Alright. Okay, so this is how we carry out the test here. Okay, so again, don't draw this graph. This is for reference only, but it is not the correct graph. Alright. Okay, so we can proceed to part number B. Okay, so for part number B, they're asking explain which of the error, type 1 or type 2, might have been made in carrying out the test in part A. Okay, so when you carry out the test in part A, right, your conclusion is do not reject the null hypothesis. So you come back to the type 1 and type 2 error, which definition give you do not reject the null hypothesis one? Basically, it's type 2, right? Because type 2 here, they tell you that you accept the null hypothesis, which means do not reject the null hypothesis, right? When the null hypothesis is false. So basically, the error that can be made for this particular test is type 2 error. Alright, so you need to explain also. So what can you do is, okay, so I'm writing it like this. Since the null hypothesis is not rejected in the test. Okay, so from here I know that the type 2 error be made. Okay, because what's the definition for the type 2 error? So type 2 error is equals to accept the null hypothesis, which is do not reject the null hypothesis, have the same meaning, right? So when the null hypothesis is false. Alright, so this is the reason. Okay. Alright, then let's continue further for part number C. Okay, so later the car dealer takes another random sample of 25 adults from the town and carry out a similar test. So we are having a similar test here at 5% significance level also. Now they want us to find the probability of a type 1 error. Okay, so to calculate the probability of type 1 error, you need to know the definition first. So definition for type 1 error is reject the null hypothesis when the null hypothesis is true. Okay, then to put in, okay, or to calculate the reject null hypothesis in the calculation, right, we basically need the rejection region. Okay, so I still don't know what's my rejection region yet. Alright, so I need to find the rejection region first. Only I can continue with the calculation for the type 1 error. Alright, so how can I calculate the rejection region? Okay, so for this kind of question, usually you should refer back to maybe the answer in the previous part when you carry out the test. Okay, so again, I want you to have a look for this diagram again, although it is not the correct one. Okay, if you have a look for this diagram, right? Okay, so 4 is actually inside or falls under the acceptance region. Okay, so I will want to bring this graph here. Okay, this is x. We are having starting the value from 0 until 25. And then I know that my rejection region is 0.05. Okay, so from the first part of the question just now, right, when we carry out the test, we know the probability of x greater equals to 4 is 0.135, which is larger than 0.05. So from here, I know that 4 falls under the acceptance region. For now, I want to find out rejection region, which means that I want to know what is the value of the x, so that when I find out the probability for x greater equals to that particular number, it is actually smaller than 0.05. This is what I need to know. Okay, alright, so what is the question mark here? I need to find the value. Okay, so for the question mark here, right, definitely you should know that this value should be more than 4. Okay, it cannot be 3, because 3, if you want to find the 3, right, so 3 will be somewhere here, and the probability become even larger. Okay, so it cannot be any number smaller than 4, it should be the number more than 4. Okay, so to calculate, to get this particular value here, you need to try an error basically. So just now, if you try to find out the x greater equals to 4, the answer is 0.135. And this 0.135 is more than 0.05. So for the next value that you want to test is, you should try out x greater equals to 5. Okay, if you want to take x greater equals to 5, means that you have to take the answer just now. Maybe I write out like this better. So I have to take 1 minus x smaller than 5. Okay, so for x smaller than 5, right, it also means that I have to take 1 minus x smaller equals to 3. That also minus x smaller equals to 4. Smaller than 5 means not including the 5, right? So I have to minus x equals to 0, 1, 2, 3, and also the 4. And I write out like this because of 1 minus x smaller than equals to 3 is the answer that we get just now, which is 0.135. By right, I will put in the long value. Just now I cut short the answer already, right? So I will just put in the original value. This value is 0.135 from the part A, which denotes 1 minus x smaller equals to 3. And now I need to extra add in. Okay, extra minus the x equals to 4, it will be 25 C4. Then the P is still the same, 0.08 power 4, then 0.92 power 21. Okay, so if you try to find out the probability here, you'll get 0.0451. which is smaller than 5. Smaller than 0.05, right? Which means that if I try to draw this x greater equals to 5 inside my diagram here, the so-called not correct diagram, and this is not a correct diagram, that means that the area for the 5 here will be smaller than 0.05. It will be something like this, the light blue one. And you can see from here, basically 5 falls under the rejection region. Just now if you calculate the 4, right, 4 is still under the acceptance region, and then 5 is under the rejection region. So from here you can see very clearly that x greater equals to 5 is the rejection region already. Okay, so since you know that x greater equals to 5 is the rejection region, therefore if I want to calculate the type 1 error, right? Okay, according to definition, it is reject the null hypothesis when the null hypothesis is true. Okay, so to calculate the reject null hypothesis, you need to put in the rejection region, which is x greater equals to 5, given that the p is equals to 0.08. To calculate the probability for x greater equals to 5, right, basically it is exactly the same like what I calculate here. Because for this calculation, we are still using the p equals to 0.08. So it is exactly the same like what I did here. Therefore, you can just write out the answer for the type 1 error where it is equals to x greater equals to 5 and the answer is 0.0451. This is the answer that we get just now already, right? So actually this value is already the type 1 error that we calculate. Okay? Yeah, so for this question, it is slightly harder because of you need to try to find out the rejection region first. You need to know. So by having binomial distribution, to try to find out the rejection region, you need to test one by one. And of course, you might need to use the result in part A, okay, as a reference for you, so that you know that for the trial error value, you shouldn't try any value that is smaller than 4. It should be more than 4. Okay, so that's why I go with x greater equals to 5. And I realize that, oh, x greater equals to 5, the 5 is fall under the rejection region already. So this is how we get the rejection region. And after that, type 1 error is equals to the probability of x greater equals to 5, which is 0.0451. Alright, okay, so this is how we answer the paper here. This is the last question already. So thank you very much for watching this video.